All right, let's take a look at question number 3. In this problem, we're going to be learning about how to carry out operations and classifications of rationals and irrationals. Okay? We're going to carry out operations and then we're going to proceed to classify our final result as either being rational or irrational. Question 3 reads, which expression results in a rational number? So that leads us to the question, what on earth is a rational number? So over here, we have examples of what a rational number is. So first of all, a whole number is a rational number. A repeating or terminating decimal is a rational number. A quotient, sum, product, or difference of a combination of 1 and 2. Okay, since they're already rational, so if you have any operation, sum, difference, product, or quotient of two rationals, your answer will always be rational. And lastly, the root of a perfect square is also rational. Okay? Alright, so let's go ahead and take a look at these problems. We're going to evaluate, carry the specified operation, and then we will proceed to classify. Alright, before we do that, let's do a real quick review on our squares and square roots. Alright? So review on squares. We're going to do squares and roots, okay? Alright, let's start with squares. Now, what is 1 square? 1 square is 1. 2 square is 4. 3 square is 9. 3 times 3. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. 10 square is 100. So it's good for you to memorize your squares, okay, from 1 to 15 at least. And then it will really help you to carry out computations involving operations and radicals and also simplification of radicals. What do these numbers tell us? Well, it tells us what the roots are. So if you root the right side, you get the left side. Okay? So the square root of 1 is 1, as we can see. And this tells me that the square root of 4 is 2. This right here tells me that the square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And square root of 100 is 10. So this just basically illustrates the inverse relationship between square and square roots. They're inverse processes, okay? All right, so let's get started. The first one, number 1, we have to evaluate this expression, the square root of 121 minus the square root of 21. So we know what the square root of 121 is, right? The square root of 121 is 11. But how about root 21? Can we simplify root 21? Are there identical common factors for 21? Well, let's see. If you break this down, 3 goes into 21 7 times. So we do not have a factor repeating itself in the decomposition of this number. So it cannot be reduced. So it stays just exactly as it is, 11 minus 21. And this number is irrational. Why is it irrational? Because the second term here has a square root. Okay, if you have that square root present in its reduced form, then it's irrational. Let's take a look at question 2, option 2. The square root of 25 times the square root of 50. Let's separate these, okay? So what is the square root of 25? Square root of 25, if you look at a list right here, square root of 25 is 5, okay? Square root of 50. 50 is not a perfect square. If you take a look at our list, 50 is somewhere here, okay? It's not a perfect square. But can we reduce this? Well, let's see. What we're going to do is decompose 50 into prime factors. Any factor that repeats, we'll group them together and bring them out as 1 because the square root of a factor times itself is just one of the factors. All right? So this is even, so 2 goes into 50 25 times. And then 5 goes into 25 5 times. Any number that ends up with 5, you can divide by 5. Now check this out. 5 repeats. Okay, so what is the square root of 5 times 5? The square root of 5 times 5 is 5. So these two break out of the radical, but 2 stays behind because it doesn't have a partner to break out with. So root 50 in its reduced form is the 5 that came out root the 2 that stayed behind. Okay? Right now that we have our 2 radicals simplified, we're going to insert it back into the problem. So we have root 25 is 5 times root 50 is 5 root 2. Now to multiply these two numbers, what you do is you multiply radical with radical and the integer with the integer. So in this case we have two integers here. We're just going to multiply 5 and 5 together, and your answer will be 25 root 2. Now because of this root 2 component present, guess what? This number is irrational. Alright, remember we're looking for what's rational. So 1 is not the answer, 2 is not the answer since they're both irrational. So we're going to keep going until we find the irrational number. Alright? Okay, so let's do this. We're going to move on to 3. Option 3, we have the square root of 36 divided by the square root of 225. From our list here, we can see that the square root of 36 is 6 divided by, if you don't know what the square root of 225 is, and you're free to use your calculator, you can take advantage of that. So just enter square root of 225, and your square root is 15. Okay? Alright, so 6 divided by 15, so 6 over 15. Now, is this number rational or irrational? Remember we talked about this earlier. If you have two whole numbers that are expressed as a quotient, if you divide a whole number by a whole number, guess what? It's irrational. Okay? We can simplify it further just for kicks. So divided by 3, divide by 3. In its simplified form, in its simplest form, we have integer. 6 divided by 3 is 2. 15 divided by 3 is 5. So a whole number divided by a whole number, it's rational. So ladies and gentlemen, this is the answer that we're looking for. Okay, let's just take a look at number 4 just to make sure. We want to find the sum of two irrational numbers, 3 root 5 plus 2 root 5. In this case, think about this for a second. What do you get when you add 3x plus 2x? What you do is that you just simply add the coefficients, right? And you get 5x. Well, the same applies here. Look at the radicals as x's. Okay? So 3 root 5 plus 2 root 5, what you're actually adding is just the 3 and the 2. So when you add 3 and 2 together, guess what? You get 5, and then you just add the root 5 component to it. 5 root 5. As you can clearly see, this is irrational also because it doesn't fit any of these descriptions here. That square root component there shows that it's irrational because you're not taking the root of a perfect square. 5 is not a perfect square. If you look at the list of numbers we have here, do you see 5? No, 5 is not there. So 5 is not a perfect square. Hence, the square root of 5 is an irrational number. Alright, so answer to question 3 is option